What makes Brian's tone so good? Most importantly, he's a really good guitarist, but also because he uses really good equipment. And not just any equipment, but a tube amp. And what makes a tube amp sound so good? The tubes inside. You're going to like this, especially if you like electronics, and especially if you like tube electronics, because we're going to use a microscope normally used for eye surgery to look inside a tube. Here we are at Memphis Eye and Cataract Associates, going to use this surgical microscope to begin our journey to the center of a tube. Today we're going to be dissecting an SED6L6GC vacuum tube. First I'm going to grab the glass envelope and pull it off the tube slowly. The first part of the tube you see in the microscope view is a plate, and that's what everybody sees when they look at a tube. Here's the top microspacer. It's made of mica, which is a type of rock which is heat resistant, doesn't burn, it's non-conductive, and it's easy to cut into complex shapes. These are the aluminum tabs for holding everything tightly together inside the glass envelope. This way you don't have to worry about problems caused by vibrations in microphonics. So when the glass envelope is slid over the assembly, these aluminum tabs are compressed against the glass, holding the assembly tight inside the envelope. These right here are the cooling fins. They are attached to the control grid inside the tube. These keep the control grid cooler to improve performance in the tube. The cathode sleeve and the filament are mounted in the center of the microspacer. You can just see the filament inside the center of the cathode sleeve. These are the supports for the plate. They run the length of the tube, and the plate is spot welded onto them. These are the getter cups, and here's where they are spot welded to the top of the anode plate. The getter cups are filled with barium, and during final construction of the tube, after the air has been removed, these barium-filled getter cups are superheated, and the barium sputters onto the inside of the glass and creates a mirrored finish. Although the flash only happens once, that mirrored finish will remove any oxygen that's inside the tube for the life of that tube. If the tube develops a break and air gets into the tube, the getter flash will turn chalky white, which is a visual indication that the tube is bad and must be replaced. These four tabs hold the beam-forming plate tight against the microspacer. We're going to bend these tabs out of the way so that we can remove the top microspacer and get into the middle of the tube. Here's the bottom microspacer, which is a duplicate of the top spacer. Okay, it's time to remove the top microspacer and get into the middle of the tube. To do this, we must first remove the cooling fins. Here's one fin right here. I'm going to turn the tube a little bit and cut the second one off right here. Now we're going to bend the beam-forming plate tabs out of the way so we can pull the spacer off the top. Now you'll see here's the second tab, the third tab. Once we pull the spacer off, you get a good look inside the tube. Now we've already cut the gutter cups underneath the microspacer, so the spacer should come off pretty easily. This is a great view because you'll be able to look down inside the tube and see the different screen grids. Right here you'll see the plate, the beam-forming plate, the screen grid, the control grid, and the cathode sleeve with the filament down the middle of it. Now let's talk a little bit about how a tube operates. To review, there are 6 elements that make up an SED6L6GC vacuum tube. There's the anode plate, the beam-forming plate, the screen grid, the control grid, the cathode, and the filament. When sufficient voltage is applied to the filament gets very hot and in turn heats up the cathode sleeve. When the cathode sleeve reaches operating temperature, a cloud of free electrons is boiled off of the cathode. A very high positive voltage is applied to the anode plate of the tube, which attracts a steady stream of electrons. These electrons flow past the other elements before reaching the anode plate. When a slightly positive voltage is applied to the control grid, more electrons flow to the anode plate. Conversely, when a slightly negative voltage is applied to the control grid, fewer electrons flow to the anode plate. In this way, a small voltage change in the control grid can make a big change in the movement of electrons, and that's how tubes amplify. Now let's remove the plate. To remove the plate, I'm going to slide it off the 2 side supports, and underneath you will easily see the other elements. Here's the beam-forming plate, notice a long opening on each side. This helps to direct or form the electron beams towards the plate. And underneath, you can see the screen grid, which is black, the gold-plated control grid, and in the center is the white cathode sleeve. I'm going to change the magnification here so we can see all the elements better. Here we can see how the screen grid and control grids are perfectly in line with each other. I'll move the screen grid to show this better. Now I'm ready to remove the beamforming plate. Once the beamforming plate is removed, the screen and control grids can easily be seen. Okay, the first grid to remove is a screen grid, and as you can see here, the screen grid is made of 2 copper supports with a thin wire wrapped around them and welded to them. The screen grid is painted black to improve tube efficiency. As we remove the next grid, you'll notice the fragile cathode coating flaking off of the cathode sleeve. The control grid is constructed like the screen grid, with 2 copper supports wrapped with a thin wire. The control grid in this SED6L6 is gold-plated to improve tone, performance, and extend tube life. The source of the electrons is the cathode, which we see here. The white cathode coating is very fragile as seen earlier, however this is where all the electrons begin. Inside the cathode sleeve is the filament. The filament wire is folded 3 times within the sleeve to ensure even heating. The job of the filament is to heat the sleeve so the electrons can be boiled off the cathode coating. I hope you enjoyed this journey to the center of a tube. Now let's see if I can get Brian to let me come play some guitar with him. Brian, can we rock him out?
Absolutely. Hit it.